Today, I want to talk about version control systems. More specifically, I will explain what versioning is, tell you about the basics of a version control system, then follow up with an overview of more advanced topics for version control systems, and finally wrap up by giving you some advice regarding version control systems in your first job as a software engineer. This is the third video in the series on applied software engineering, but the second one that talks about the proverbial tools of the trade and processes that are widely used across the software engineering industry today. This video is intended for an audience that is interested in finding out more about the software engineering profession but has little experience in the industry. Alright, I think that's all that you need to know before we begin, so let's get to it. Before we can get to the really interesting parts of version control systems, we simply have to start with definitions and basics, as otherwise most of the more advanced topics will sound like nonsense to you. The very first thing that I need to define is the notion of a repository, and in the context of software engineering, a code repository. Think of a code repository as a folder that contains everything that is necessary for a specific project that you're doing. It can contain subfolders in it, such as a folder with all the pictures you have on your site, along with a different folder that contains the front end for a website, as well as a folder for the back end. Obviously, this notion of a repository is fairly general, and can be applied to basically anything, from financial analysis to graphic design. Now that you understand what a repository is, I can finally introduce the concept of versioning. A version is just a view into what the repository, or just a single file in the repository, looks like at a specific point in time. As an example, let's say you have just a single file in your repository, an essay that you're working on for a class. If you ever worked on an essay, or any involved report, you know that you will make multiple passes when writing it. You first make a draft, then you proofread it, and clean it up, then you go back and correct some spelling mistakes, and so on. If you are clever, you likely make copies of the essay file at each point in time when you are done with working on it. However, in a regular folder, this typically leads to a whole mess of copies of files with you not knowing which one is truly the latest. Admit it, you have at some point had a file named something like English 102 report.docx, parenthesis 4, parenthesis final, parenthesis really final. This sort of versioning is not ideal. It would be nice to have a single file that just shows what the latest version looks like and have the ability to go back to whatever previous version you had whenever you want. This is precisely what version control systems do. In essence, a version control system will display the latest version of each file in a given repository and provide a convenient way to look at what each file looked like in the past. Additionally, version control systems allow you to not just move back in time for an individual file, but also see what the entire repository looked like at a specific point in time. There are many different version control systems, but the most common ones that I know are Git, Perforce, Mercurial, and Subversion. Now, I only ever personally worked with Git and Perforce, but I know that a custom version of Mercurial is in use at Google, and that Subversion was used a while back. Git is very popular, and that's the one that you'll most likely learn and use. One thing that I would like to address here, GitHub, GitLab, Gerrit, and Bitbucket are all web frontends and Git hosting services that use Git underneath. You can actually self-host a Git repository if you want, but most of the time, you'll work with some Git repository manager, most likely GitHub. Alright, let's get to the last couple things in this section, first of which is a really basic workflow that essentially any version control system supports in one way or another. In essence, when making changes to your repository that you want to be reflected in the version control system, you will do the following steps. First, you will make whatever changes that you need. Let's say that you add a couple lines of code to a couple files on your local machine. Once you're satisfied with the changes that you have made, you will stage them for committing. Then you commit the changes, and once you think that all the commits you made should be reflected in the repository, you push the commits. I used a bunch of jargon here, so let me just give you a simple mental model regarding the terminology. Essentially, think of staging as getting a box and putting all those changes into the open box. While the box is open, you can add and remove changes as you wish. Now, once you're satisfied with what is in the box, you close the box. The act of closing this box is called committing. A single commit is typically a whole new version for your repository. Now, in the process I described above, all the changes and commits are still local to your machine. Once you're ready to make sure that the repository or whatever service holds it for you knows about the changes you made, you push all your commits. A push is essentially the same thing as taking all the boxes you have created at home and shipping them out to the warehouse that holds them. In other words, you push the commits that you have made from your local computer over to the repository stored on GitHub or whatever other service you use. The last thing that you should be aware of as a beginner is that version control systems quite often allow multiple people to work on the same repository, and thus it's actually a very convenient way to share the changes with everyone else. And the main repository typically resides in some centralized-ish server that everyone can access. Alright, I think that's about it for the beginner level information, so now let's get to the much more interesting stuff at the more advanced level. So far, we have talked about the basics and simple workflows that only really work for single individuals and tiny teams. However, software is often written by many large teams, and the overly simple workflow I have shown in the previous section simply does not scale up to the needs of large organizations. Therefore, we will need to talk about branches and merging changes and branches into other branches. Before we get to that, I need to briefly state something. From now on, assume that all the changes are happening to code files and not to images, Word documents, or other binaries. This will make reasoning about what I'm going to talk about much easier. As I already said, we need to talk about branches. A branch is simply a parallel universe of sorts that starts from a particular version in another branch of a repository. Yes, I just gave a recursive definition, but it sort of makes sense once you realize that when you start making commits to a repository, you're simply committing to the mainline branch. At this point, I think it would be irresponsible for me to not show a diagram, as diagrams make it much easier to think about branches. Here is a simple diagram that shows a mainline branch at the top with 5 versions, or commits, in it. As you can see, there is also a branch below it that starts from version 2 of the mainline branch and has 2 more different versions in it. You may have a question: why would you make a branch in the first place? The answer is fairly simple. With branches, you can work on your features without the changes that are happening in mainline from disrupting your work. Also, the changes that you are making in your own branch will not disrupt mainline either. These are pretty big benefits. Therefore, the more common workflow is to create a whole new branch when working on a new feature and work off of that. That way, you have a stable environment where you can do whatever you want, even if it breaks everything. After all, pushing things that break to your own branch will have no effect on the mainline branch. Allow me to briefly introduce some terminology. In the diagram that I showed you before, the feature branch on the bottom is a child branch to the mainline branch. The parent version of the branch is version 2 of the mainline branch. Now, in this diagram, what if you want to have the changes that are introduced in version 4 of mainline within your feature branch? Well, you could patch it in manually, but that's pretty annoying. The more standard way to do this is to change the parent version of the feature branch to version 4 by using the process called rebasing. What this will do is take the change you made to the original version and try to apply it to the newer version. This is typically done by patching a diff file in, which means that only things that are different are changed and everything else stays the same. This process is automatic most of the time, but sometimes needs manual intervention to get right. Alright, I think it's a good time to talk about what you can do once you have finished developing your feature in your own branch and want the changes to be reflected in the mainline. This process is called merging, and I will talk about and show diagrams for 3 common ways to merge. The first way is to simply merge the 2 branches together. The idea here is that you ask the version control system to make the changes from the head of the branch become part of the mainline. The version control system will make a new commit that combines the 2 branches if it can do so automatically, or have the developer do it by hand for parts that it can't really figure out on its own. This is called a merge conflict, and as a developer you will deal with them relatively often. Resolving the merge conflict is the manual intervention step that I mentioned before. One thing to note is that the version control system will be able to keep the history of the branches as shown here with a simple merge, meaning that you can see what changes were made with the feature branch independently of the mainline branch. Next approach to merge the changes in the feature branch into the mainline is called squash and merge. This effectively combines all the commits inside of the feature branch into one and merges that as a single commit into mainline. This can sometimes drop some parts of the version history, but is still a very common approach to merging. The last approach is to rebase and merge. This first moves the parent for the feature branch to the head version of the mainline branch, and then moves the head to the front of the feature branch. This is a common merge strategy for smaller changes, as it can completely hide that a set of changes was actually a whole branch, but is still widely used in industry. Each merge strategy has its pros and cons that you will likely learn over time, and there are also other more niche merging strategies that you will only really learn on an as-needed basis. Also, it's common to call this merging of feature branches into the mainline as a pull request, which ties back into my previous video on code reviews that I suggest you check out later. Now, as part of the advanced topics, I simply need to talk about two more things: using version control systems for release management and change tracking functionality. Let's begin with the harder idea first: release management. You can create a release branch for software that is parented to some specific version in the mainline that is never rebased or merged back into the mainline. This is actually a relatively simple way to version your releases, and it allows you to make changes in a specific release without changing the mainline, and change the mainline without changing old releases. Now, when it comes to the change tracking functionality, this one is far simpler to wrap your head around. As you make changes to a file, you have a list of all changes to that file as part of the version history. This means that there are ways to view what commit changed each line in a code file, which is useful to figure out who made a specific change. This is a very common feature across all version control systems. Within Git, you can check the line-by-line version history of a file by typing in git blame and providing the file. And in Perforce, you would do the same by typing in p4 annotate and providing the file as well. I'm sure that Mercurial and SVN have their own ways to do this, but I never use them. Alright, there are many more advanced topics that can be discussed, but in the interest of time, I would rather move on to talk about the advice I have for you related to using version control systems at work as a software engineer. This section of the video will be short, but I think that you will find it very useful. In brief, I will provide you with the necessary questions that you will want to find the answers to either from reading documentation at work or by asking your assigned mentor about what processes you have at work. The very first thing that you should find out about your workplace once you start is what version control system your organization or team uses. This is important, as it may be something that you are not familiar with, and thus being proactive to ask for documents that talk about how to use the version control system at your workplace is a very good idea. The next thing that is worth finding out is the development model that your team uses. This is quite important, as you should try and use the version control system in roughly the same way that the rest of your team does, so that they can help you when you hit some issues while developing features. Keep in mind that the development model may be different at each place you work. As an example, the development model that a team may use is effectively having only one commit in the pull request and amending it as code review feedback comes back. This makes the rebase and merge strategy work really well, but each company is different. As I just mentioned, the development model may be different because the team tries to accommodate a specific merge process that makes the workflows within the team be much less error prone. Therefore, find out what the pull request merge process is like early, since if you try to go against the grain, you may break some tooling that the company added. The next piece of advice is actually to play around with the tools that you have access to right away, in order to get used to the version control system you will be using. Try creating a new branch and add new commits to it. Get used to adding new files to the version control system, and figure out how to explore the version history with tools like git blame or p4 annotate. Also, do learn how to roll back changes correctly. If you break something in a local branch, or worse yet, in mainline, you will want to know how to undo the changes quickly and correctly. The last piece of advice I have for you is to find out how releases are managed within your workplace. This is mostly applicable to full-time employees, as interns are often shielded from having to backport changes to releases. But if you're a full-time employee, learn how to do this early. You will want to learn what the process is like to update a release branch and how to merge the changes into it early, as you are likely to learn it better when you are relaxed and aren't stressed out about the regression that you are trying to fix in said release branch. If your company does a rolling release model, then you need to find out how to update the production environment instead, and as I just mentioned, it's best to learn this while relaxed. You are likely to make fewer mistakes if you aren't doing these things for the first time while under serious pressure of a production outage. And with that out of the way, I think that's all the advice I have for you. Therefore, let's get to the video's conclusion. In this video, you have gotten a high-level understanding of what version control systems are and what sorts of workflows exist within larger organizations when developing software. In addition to that, I gave you some advice regarding what questions to ask about the version control systems your workplace uses as you start a new job as a software engineer. While a lot of the information I have tried sharing with you here may seem a bit too abstract if you're very new and have never worked in industry, it should still serve as good context for what the tools of the software engineering trade are, and a decent reference for when you just begin using version control systems within a professional environment. Either way, I really hope that this video was helpful and interesting for you. feel free to check out this playlist here to watch all the videos I have on the topic of applied software engineering, especially if you're watching this in the future when I've already uploaded the whole series. Also, feel free to ask questions if you have any. I try to respond to all the comments I get and have made a few videos based on viewer requests so far. Anyway, thank you for your time. Bye.